In today's video, we're going to be doing Pythagorean theorem scenarios. So we'll be given a word problem with a certain scenario, and we're going to have to draw a diagram and use Pythagorean theorem to solve the scenario. All right, so in our first one, it says you start driving west for 5 miles, turn left, and drive south for another 8 miles. At the end of the driving, what is your straight line distance from your starting point? Round to the nearest tenth of a mile. Okay, so we are driving west for 5 miles. Boom, boom. There's out west. And then driving south for another 8 miles. So this is not drawn to scale, but I need to find the straight line distance from your starting point to your ending point. And we know this is a right triangle. And look at that. We have 2 legs, and we're solving for the hypotenuse. All right, so we do 5 squared plus 8 squared equals x squared. When we plug them into our Pythagorean theorem, 25 plus 64 equals x squared. 25 plus 64 is 89. And then we find the square root of both sides. And we use our calculator. So we know this is the square root of 89, which is about, let's see, square root of 89 is 9.4. All right, and that would be my answer. Okay, so again, use the scenario, draw your diagram, use Pythagorean theorem, figure out you're trying to find the hypotenuse or the leg, and solve. Let's look at another one. Okay, I'm going to make myself some room here. All right. If you place a 37-foot ladder against the top of a building and the bottom of the ladder is 22 feet from the bottom of the building, how tall is the building? Round your answer to the nearest tenth of a foot. Okay, so again, I'm going to draw my diagram. I'm going to make a ladder, or I'm going to make a building first. There's my fancy building. We'll put a door in the front. All right, and then I have a ladder going against the building. And all right, so I'm going to extend the ground here. Now, even this crooked ladder, it's tough to see maybe where the right angle is. Let's take a look. All right, so you have a 37-foot ladder. So I know this is 37 feet, right? That's 37 feet. And it's from the top of the building, and the bottom of the ladder is 22 feet from the bottom of the building. So this part right here, bottom of the ladder to the bottom of the building is 22 feet. And notice you have a right triangle in here. Here's your right angle, right? And it looks like in this case, we're trying to find the leg in this scenario. So 37 is the hypotenuse, 22 is the leg, x is the other leg. So we have x squared plus 22 squared equals 37 squared. All right. I don't know 22 squared and 30 squared off the top of my head, so I'm going to have to use this thing. 22 squared is 44. I can't draw an 8. What's wrong with me? There we go. 37 squared. 37 squared is 1369. I'm going to minus 484 from both sides. And I'm going to get x squared is minus, what is it, 484? 885. 885. Okay, find the square root of both sides. So I know this is the square root of 885. And now I have to round it to the nearest tenth, which is about, let's see. Square root of 885 is 29.7. 29.7. All right. So that one we had to find the leg. All right. Let's look at another scenario. Okay. The area of a rectangle is 105 square units. Its width measures 7 units. Find the length of its diagonal. Round to the nearest tenth of a unit. Okay. So drawing a rectangle this time. All right. The width measures 7. All right. And we know the area is 105. Okay. Remember, area of a rectangle formula is length times width. So if I already know the width, right, and I know the area, so I have to just do a little simple math. We know the area is 105. We know the width is 7. So 105 is going to equal 7L. Now I got to find the length. So I divide both sides by 7. And 105 divided by 7. 105 slash 7 is 15. All right. So that means this is 15. Means this is 15. Find the length of the diagonal. So we're not done yet. We have to still use Pythagorean theorem to find the length of the diagonal. And that, in this case, it's going to be, we'll call that x. We have my legs, and we just got to find the hypotenuse. All right. So we have 7 squared. I'm going to write to see if I can fit in here. 7 squared plus 15 squared equals x squared. So we have 49 plus 225 equals x squared. Again, you could use the shortcut with your calculator. I don't know, it could have done this, but so this would be 274 equals x squared, and then you find the square root of both sides. You could have done that. Or you could have done this from the beginning, right? This right here, square root of 7 squared plus 15 squared. So I put that in my calculator. Square root of 7 squared plus 15 squared. Since I'm finding the hypotenuse, it's about 6.5, right? Now, if I did the same thing with the other numbers, should get the same answer, unless I made a mistake. Then I'll go back and see it. Yeah, same thing. All right, so 16.6, right? If you look after the 5, it's a 5, so it bumps it up to a 6. So be careful when you round. So that is going to be the length of my diagonal, right? So this is going to be about 16.6. right, so we just had to do a couple manipulations beforehand. Remember, the area of a rectangle is length times width, and you just got to divide the area by one of the dimensions to figure out the other dimension. That's why it's always helpful to draw the diagram. All right, let's look at one more. Ooh, another ladder one. A 50-foot ladder is set against the side of a house so that it reaches up 40 feet. If Aisha grabs the ladder at the base and pulls it 9 feet farther from the house, how far up the side of the house will the ladder reach now? Okay, the answer is not 31 feet. Okay, round to the nearest tenth of a foot. All right, so we have to do, all right, basically our building and our ladder again. So I'm going to draw the building over here. All right, at first, the 50-foot ladder reaches up to 40 feet. Okay, so my 50-foot ladder, I'm going to say, I'm not going to draw the ladder part. I'm just going to say this is 50, and it reaches up 40 feet. If Aisha grabs the ladder at its base and pulls it 9 feet farther from the house, so the ladder still stays the same. It's just going to go 9 feet further. So what I think I'm going to do first, before I do that, is I'm first going to figure out the original length of what my base was supposed to be. So I'm still going to try to find this. Okay. So before Aisha even grabs the ladder, I want to find this distance first. All right. So I'm going to call this X, and this is the leg. So I have to find the leg of this right triangle. So you have X squared plus 40 squared equals 50 squared. So you have X squared plus 1600 equals 50 squared is 2500. Minus 1600 from both sides. And you get 2500 minus 1600 is 900. Find the square root. Bada boom, bada boom. And you should get 30. I'm just going to double check with my calculator. Oops. Square root of 900 is 30. Yep. So we know this is 30. What happened there? No. So we know this is 30. All right, now let's get to the part where Aisha grabs a ladder and pulls it 9 feet further. So if she pulls it 9 feet further, boom, 9. The ladder height is still staying the same. It doesn't go anywhere. It doesn't change any difference. All right, so now it's 39 feet from the building. Right, when I add these two together, it's 39. The ladder stays the same, doesn't change in height, but now it's going to be located lower on the building somewhere. So that's still going to say 50 feet. Now I want to try and find this part right here, which I'm going to call Y. I'm just going to call it a different letter. All right. So I have my ladder that still stays 50 feet. Now the length from the building is 39 feet, and I have to find the height where it reaches. So again, that's a leg problem. All right. So I'm going to do this over here. In blue, we have Y squared plus 39 squared equals 50 squared. I know what my 50 squared is. It's 2,500. I don't know what 39 squared is off the top of my head, like I knew the last ones. So let's figure it out. 39 squared is 1,521. I'm going to subtract that from both sides. And you get y squared is 2,500 minus 1,521. $979. Find the square root of both sides. And this is rounded to the nearest tenth. Okay. So rounded to the nearest tenth. 979. Square root of 979 is 31.3. So it's close to 31, but we want to round it to the nearest tenth. So it's 31.3. So that would be the distance here. Let me highlight it. This distance right here. That's 31.3. Okay. So this one kind of required a little bit of steps, but drawing the diagram definitely helps when you're doing these types of problems. And as long as you remember the Pythagorean theorem and find the square roots and rounding correctly, you should be good. All right, so that's it for today's video. And always remember, whether you're solving for X or Y, always give math a try.